can.
Okay, so we are live now. Hello, everyone. This is the Foreman Remote Execution deep dive that we would like to first go over the features that we have currently implemented so that you know what we are talking about. Then we would like to go more over the implementation details or technical details that should give you more insights on the architecture and how the whole thing works together. And then we would like to talk about the future, about the short-term and long-term plans, and we would like to leave the rest for the questions and answers and general discussion. So the Q&A app is on, and you can start asking questions as they pop up in your head. So that's our agenda today. So first, please, Marek, for the demo of the features that we have right now.
Thanks. So hopefully you can see my browser right now. I will start by end-to-end demonstration of what we can do today with the plugins. I mentioned plugins because it's not just one plugin. It's composed of two plugins. One is on the Foreman side, and this provides you the UI I will demonstrate right now. And the second one is on a smart proxy. So all the communication goes through the smart proxy when you try to run some execution or some job. So let's start with the UI in a Foreman. So first, what you have to do is to define a job that will be triggered on some target machine. So to do that, we reuse the common concept in a Foreman called templates. It's very similar to what we have for the provisioning templates or partition tables, and it's called job template. So under host menu, you can see that there's a new option, job template. And here is the list of all templates we have. I already have some of them, and nothing prevents me to create a new one. So it's very similar thing. We can define the command here. So it could be something like ping google.com or anything else. Increase the font so you can see it there. One new thing here is the job tab here, which is something specific to the job template, and other things are very similar. So you can see a history, you can assign it to a specific location, organization, stuff like that. So I don't want to create something here, but let's see what I have already defined. So the simplest example I have is just a ping command here. So as you can see, this is just a shell script that will be triggered on the targeted host. Here I can see the preview, which here just displays the same output as a code because there is no dynamic part. But I can add some ERB tag here, which is going to be evaluated. So here I can use the very same variables as for provisioning templates. So for example, I can do something like host.fqdn. Now when I click preview, well, FQDN is not whitelisted attribute here, so I can't use this one. But I could do something like input, and here I can use the input name FQDN. And this input is a special macro, so you actually define the variable that will be used. The input is defined in a job tab here, and it basically says find an input that I define in a job tab with name FQDN and evaluate its value. So here you can see I have an input with the name FQDN, so this input will be used instead of that ERB tag when the template is rendered. And you can see it can be based on some fact value. So it searches the fact for a given host with the name FQDN. It searches its value and pastes it here instead of this ERB when it's rendered. The rendering is done on the Foreman side, so we can use all data we have in Foreman, and then the rendered template is sent to the smart proxy, which then connects to the target host and executes the script. It's wrapped in a script that is first uploaded to the host, and then it's executed. As far as I know, we currently can't set a shebang here. Maybe Iwan can correct me if I'm wrong. So I'm not sure if you can do something like this, but I think we hard code the shell that's used.
We hard code the first one, but the shebang of this script itself gets executed inside the SSH session, so we should apply.
Okay, thanks. So back to the inputs. Here I used the one based on the facts, but we also have another types of inputs. So you can see here that we have 4 of them. So fact, that's obvious. User input is something that user has to specify before the execution is started. So it can be any arbitrary input, which is usually different for every execution. And then we also have variable and Puppet parameters. Variable is based on the host's parameters or smart variables, and the Puppet parameter is very similar, but it's using the parameter for the Puppet class that's assigned to the host. So you have to specify the class name and then the parameter of this class name. Okay, so let's see something more interesting. So here we have very similar script that uses one input that passes the input value to the message of the day file. So it's user input here. Here we can do the previewing. The previewing works for a host that I specify here. So this host doesn't, or the user input is not provided yet. So we can't really evaluate the value here, the result of the ERB tag. So we put a placeholder here, so it's obvious that it's going to be specified by the user. If I go back to the input, I'll put it here again, which is based on facts, and I do preview now. I want it for this example host, for this AA example, because it doesn't have facts, so it can't be evaluated right now. But if I search for some host that does have facts, it should work, and we can see that the value is evaluated here. So the ERB tag is replaced by its actual by the value of the actual fact. So these were 2 simple examples. By default, we provide 4 templates for you. So it's the first 4 you can see on my screen. So package installation or package management, which means you can install package, and you can also update a package or remove a package. So first, if we look at the template, you can see that the main action is here, and we use host here and check its operating system family. If it's Red Hat, we use yum for the package installation. If it's Debian family, we use apt-get. So you can do basic if conditions like this. What's more interesting here is that the inputs can also have options. So for the input action, which is user input, you can restrict the value to be one of the following values. So when we render the form, it's not just a text field, but it's a select box, so you can select one of these valid actions. We also have an action for triggering a Puppet run. You can specify custom options for the Puppet run here. Run command is simple. template that allows you to run any arbitrary script that you can specify during the job invocation. I'll show it in a minute. And the last one is for managing services. And again, you can see that if the family is Red Hat and it's recent rel, we use systemctl instead of service. So this is just a definition of the jobs that you can trigger on your host. So now let's see how you can actually trigger something. So you have to first go to the host page. You can either run a job for a specific host. Let me just go to the host detail first. And here you can see that there is a green run job button. So when I hit this, I'm redirected to the form where I specify all the parameters and the job. So let's start with the ping, for example. So here I select a job that I want to run. Here I specify these two fields, bookmark and search query, allows me to specify the targeted host or even more hosts. But right now, I just want to run it on one host. Here I see that it will be triggered on one host. Type of query is currently, well, it will be more important later when we add scheduling of execution to the future. Basically, it says if I specify the target as some more advanced scope search, the evaluation of the scope search syntax should happen either right now when I click the submit, or if I select the dynamic, it will be evaluated just before the execution should happen. So if I schedule something to happen in 1 week, the query, meanwhile, the result of the query can change. So let's just see what happens right now if I run the ping on one host. So I'm redirected to the show page of this invocation. I see the overview here. Right now, we don't have any automatic refresh, but there is a refresh button. So if you click refresh, you can see that it was actually scheduled, and all hosts are in pending status. So let's click refresh again. And hopefully in a few seconds, we should see the result. So meanwhile, I can describe what we can see here. Basically, this part tells you on what targets was the invocation triggered. And here we see what template was used. And here we also see the preview of the template. So we can see that it tries to ping Google.com, and it tries, there are 50 tries. So it takes some time. Now we can see that it succeeded. So we can go to the detail and see that on this host it was successful run and look at details, but I won't do that right now. I would like to show you how you can trigger the same thing on multiple hosts. So back on the host page, I can select any number of hosts here, and there's a multiple action run job. And the only difference here is that it generates the search query for me. So you can see that it resolves to 10 hosts. You can do it like this, that you specify the host exactly, or you can even use the bookmark. So you can select a bookmark here, and it will update your search query. So this is the query defined by the bookmark. And you can also specify a different query here. So for example, if I do some syntax error or something, you can see that it resolves to 0 hosts. So if I change it back, it's back to 10 hosts. So let me just run the ping here again. So now you can see that I use the dynamic search or the query here, and that I see the preview here. And because the preview might be different for different hosts, we pick the first one and display the preview just for a specific host right now. We plan to improve that so you can select which host you would like to see. Now we can see that first we have a first failure. Others seems to work, so it will take some time. But meanwhile, we can check what went wrong. This is actually expected, and you can see that on my target 2 there is a failure. So you can go to details. We plan to improve this page quite soon, but for now we use the UI from the Foreman tasks, so it might be a bit harder to spot the right and most important information. But here you can see that there's an output that ping failed because unknown host Google Chrome. So if we check that host and we look at resolve con, we see that there is no name server, so it can't really resolve the Google con. So let me fix this issue. Now, if I go back, I can rerun this invocation, which would rerun that on all of these hosts, or I can rerun only on the fail host. So I'll open a new tab to rerun only on this failed host. It shows the very same form, but now I can see that it will trigger it only on the specific target host, and it pre-filled the ping command and everything. So now when I submit, it should run it on the host on which it failed. So meanwhile, let's refresh the bulk action, and we can see that the rest of them was successful. And on the host that I fixed, it will take a while, but it should also be green right now. Okay. Meanwhile, let's try something else. So we can also rerun the job, but we can still change anything in this form. So we can, for example, do the package installation. And here you can see that the form is generated based on the inputs we had for the job template. So we can install, update, remove. So let's install, let's say, Midnight Commander, and submit it. Now when we check the ping for the host that failed previously and we fix that, it seems that it's green. And for the package installation, it will probably take a long time. Maybe on some of them it's already installed, so it succeeded earlier. We could also cancel the job. So now it contacts the Foreman proxy or the smart proxy, and it tries to cancel the running jobs. So yeah, so it seems that it was canceled on those that didn't make it on time. When we check the details of some success run, we should see the output of YAM that was installing the Midnight Commander. Yeah, so it says nothing to do. One last screen I would like to show is just an overview of jobs, so you can see what was executed before and the status here. So you see how many hosts had a successful run, how many failed, stuff like that. And from here you can navigate to the invocation detail, so you can rerun it later. So I think that's about it, unless there are any questions regarding the UI and stuff I just presented.
We have a couple of questions, so I will try to select the ones that are related to the UI part. So first one is not the question, but the suggestion that there should be a flag that would cancel the execution if first 10% of the host fails, because that probably means that something goes wrong, if I understand it correctly. Yeah, we are open for the suggestions. Maybe Mark, you have something to say to this, but anyway, I would suggest filing the issue or RFE in the projects page or in the Redmine right away, so that we can track and continue discussing for these features. Yeah, so Mark is already showing that we have the issue tracker for this. So another question is, what is pending state in the job invocation, I guess. So I will try to understand or answer right away. So the states are now, right now, are taken from the Foreman task and the time flow. So the pending might not be the best word to use there. It basically means that we don't have yet the result from the host. So everything that's not finished yet, so either failed or success, is in the pending state right now. Yeah, and
but would failure to schedule, or let's say we didn't talk about the architecture, but when Foreman schedules a job that goes and executed through a proxy, and if the proxy is not available, for example, it would still also be pending, right?
Yeah, so until it's basically we say we are not going to reach the proxy anyway, we switch from pending to failed. Right now there's also a pull request for handling this state, where if fails on for the first time, it waits for some time for the timeout and then retries again, and there is ability to specify a number of retries. So yeah, but we need to improve the tasking so it better describe what's going on right now. So right now pending means we don't have the answer that it started or not. So if something fails, so right now if it failed, talking to the proxy, it would be marked as failed right away. So another thing is a suggestion for Hammer commands, and we have that as part of the plan. We did, we talked about that in the design phase. We don't have the Hammer action just yet, but we would like to add it sooner than later. So the question is how to cover that or reflect the thing that happened in the UI with choosing the templates and the job. So there might be a question for the usability for the Hammer action. So we definitely will ask for more feedback once we start implementing the Hammer actions. There are a lot of questions. So I will select here. This is done as well. How does one configure smart proxy? So how does one configure a smart proxy for SSH connections? I will talk about it in a minute. No need. There was no need for SSL exchanges because I think the Puppet run feature in the smart proxy also requires the SSH to be opened or to be able to open the SSH connection. So as far as I know, when I was testing the production setup, I didn't have to disable Linux for that. But I will talk about the setting up and how the authentication works as well in a minute. Another question, if the jail warning indicates that the save mode is not supported. No, the problem was that the FQDN of the host, if I not mistaken, is not allowed in the save mode at all. So if you use something like host.name, that should work. So it's really the same as we have in other provisioning templates, nothing extra here. Another question is, can I run on a specific host? regardless it's failed or not. Maybe Marek, you can answer this question.
So if I understand correctly, you can run on specific host either from a host detail, or if you are if you now click rerun, you can still select a specific host here just by saying name is target, let's say 1. Just make sure resolves to one host, so it will run this invocation on a specific host.
Thanks. Would be nice to see maybe it relates to the hammer actions. So I'll make this down as if there's something else nice to see, we'll see it as the next question or in the issue tracker. And the last question is about the importing of the keys. So we'll leave this for the authentication. The next part that we would like to get through, unless there are more questions, I can check RC just in case. Okay, it seems no questions on RC if I haven't missed anything. So thanks, Mike, for the demo and answering the questions. The next part is getting more into the architecture details. So let me share my screen. So I hope you see the inception. So as you saw when we yeah, and I skipped one question, which was if one can specify which shell or interpreter is used for running the script. I wasn't sure, but I've just tested that you could run Ruby with this template, a Ruby script, and run it as the remote execution action as well. So from the architecture perspective, we talked about the architecture when doing the design of the remote execution, and let me just find the pages here. So this is the plan that we had, and we more or less implemented it in that way. So when you run the command on the Foreman server,
Ivan, can you just increase the font, please?
Definitely. Thanks. So when the user triggers the job invocation on the Foreman server side, it gets the invocation gets evaluated. Basically, it looks at all the hosts that needs to run the command. It renders the command itself and sends this to the proxy. So what does it mean in real world? Is that when I'm in a job, there is on the backend there's a task that evaluated the whole thing, and we use the Dimeflow for that. So there's a bulk task. So one task is responsible just for making sure all the subtasks are running and handles the failures and so on. You can also use this as the entry point when you want to cancel everything. And it consists of the tasks that represent running of on several hosts. So this represents running the task on specific host, in this case, the host ID 15. This is pretty low-level stuff, but this is a deep dive, so we would like to talk about it anyway. So this means on the Foreman server side that some script gets run. What this task does is contacting the smart proxy that should be used for the execution itself and says, please run this this command. I will go to the Dimeflow console to have even lower level insights. So it says, please run this script. So this is evaluated template on a host.
Ivan, sorry, can you increase the size again on all of your windows? Thanks.
I'm not sure if I would be able to do that, but I will try to increase continuously. So there is, in the input of the task, there is the host name that we would like to send or SSH to. There is the evaluated script, and there is the proxy to be used. This I will talk about choosing the proxy later. Then on the smart proxy side, so these are two Dyneflow consoles, but you should notice the URL changed, because we choose to use Dyneflow on the Foreman proxy side as well, especially for the async processing stuff that we have in Dyneflow, and it didn't make many sense to use something else for this cases. It also us also doing some additional stuff as canceling and so on. So we basically got the same input, the same thing as the input for the task. So let me find the one that I've shown on the. So this is part on the Foreman server. This is what was executed on the smart proxy. The smart proxy can run on the same server or something somewhere else, so the network reachability is not that issue, as long as you have the proxy that sees to the host in there. So the Foreman doesn't have to see directly the host to open the connection. So we got the script as well, and we assigned the task ID to it so that we can link these two together. The smart proxy then executes the command. So when I switch back to the design, you can see that it executes the script and collects the progress. Here in the design, we designed that we would send the accumulated progress to the Foreman server so that we can show the ongoing or almost real-time updates. We'll probably choose a bit different strategy for now, as usually one is not, or we would not use this accumulated progress report, which basically would mean just the latest output most of the time. So what we will probably do is, when somebody requires for runtime updates for some job execution on a host, we will probably reach the smart proxy from the Foreman server on demand for getting this data in real time, instead of sending the progress just at the end. So we can ignore this part for now. So it means we basically the smart proxy handles the execution of the script, and once it finishes, the smart proxy sends the data back to the Foreman server. So for those that are interested in details, there is the second part of the workflow in this smart proxy command that is responsible for calling back to the Foreman and sending the data. So this is the data that will be sent to the Foreman server side. Then on the Foreman, we save this data to the output, and we can use this data for further processing. So right now we show it just as the output in the tasks, but we will show it also in the remote execution specific UI later. And also we haven't talked that about this much, but we would like also later start processing this output from the scripts and saving it into let's say reports, also or transferring it to the state if it makes sense, to give more or better ability to work with this data later. So right now we have this just as the raw data. We collect also some additional metadata about this. You can see that we can distinguish what was sent to standard output or standard error, and we also collect the timestamps about the output. So we get the outputs from the SSH, and every time there is something new, we make a mark about when it was. So this also could be quite a nice thing to process on. So you could basically analyze how long some part of the script took. So that's basically the process, how the thing works. So we have 4 plugins involved in this thing. One is the Foreman task, just as a backend or runtime for Dynflow and the tasking functionality. On top of that is the Foreman Remote Execution plugin. There is explanation for this in our documentation in the Foreman org as well. So this is basically the SSH part or the UI for the remote execution on the Foreman side, including API as well. Then we have 2 plugins also on the Smart Proxy. The Smart Proxy Dynflow is more or less equivalent of the Smart or Foreman task on the Foreman side. So it basically provides the Dynflow runtime and initiates the Dynflow console and so on. And it basically provides the connection between the Foreman task and the Dynflow on the Smart Proxy. So you can basically say that you want to trigger something on the Dynflow or on the Smart Proxy Dynflow side through the Foreman task, and these 2 plugins are responsible for exchanging the data. So the Foreman task plugin is able to call to the Smart Proxy Dynflow to execute the external task, and the Smart Proxy Dynflow is then able to send the data back to the Foreman task when it finished. So we did in this way that other plugins could use this as well, and we don't have to include any of this logic in the Smart Proxy Remote Execution SSH. So what this plugin does is basically just implementing the connector between the Smart Proxy and the SSH, and it implements the Dynflow action to be run, to be executed to run the SSH commands. So that's basically about the internal architecture. I will look if there are any questions regarding this. Can I get this question? So first question, which kind of data is on the proxy side versus Foreman database? So on the proxy side, we collect just the runtime data. So the raw data that we can get from the execution. So I hope I answered most of it. So it's basically the standard and output standard error, exit codes, and including the timestamps. All these data are meant to be just let's say runtime data. So once we send it to the Foreman side, we haven't implemented this yet, but there should be cleanup mechanism. So one should not rely on using this data in a year or 2 years. So it's more about the runtime data to collect the outputs as they appear and sending to the Foreman server. Maybe we can do some pre-processing, but it's not meant for long-term storage. On the Foreman data, in the Foreman database, at the end, we should get all the data that we have collected in the on the Foreman proxy side, and then process it later. As I mentioned, the Foreman also the Foreman tasks with the raw data might get cleaned. Later, we have this functionality. So for the important data, there should be a mechanism for processing that and getting into, let's say, reports or something that is more usable by the users, but we haven't implemented this yet. I hope that answers the question. I will talk about the SSH keys later. So another question about the workers. So we use Dynflow at the back end, and Dynflow is multi-threaded using concurrent Ruby. We also try to minimize the time that the threads are blocking something. So if there's no such a thing as sleep inside our code, we just wait for the output. So currently Dynflow runs 5 workers in a process, which I haven't tested that too much, but when I did some tests some time ago, I was able to get into hundreds of concurrent runs, and it wasn't with SSH. I used the system execution, but I hit limits on the user side for opening or running the new session. So the number of workers should not limit the number of SSH connections. We need to do more testing on that and give proper recommendation on how many workers, or let's say Dimeflow executors, you would need for bigger loads. We might hit memory maybe more than the number of threads. We could hit memory issues with SSH connections. So we need to do testing for that. And for the limiting numbers, what we should do is basically spreading the hosts between more proxies or between more Dimeflow executors. So Dimeflow is able to run multiple executors on the same host, or spread that among multiple hosts. This is maybe more also a question for HA mode and load balancing on the smart proxy side in general. So we have just partial answers on the possible ways that we can tackle this, but we need to do more testing on that to give more details. Next question is about the archiving the job results. So on the smart proxy side, we'll clean them regularly, as they are not meant to be used later. On the Foreman task or on the Foreman server side, the Foreman tasks have ability to clean tasks based on some parameters. So and this is question for the users, or how you configure the whole thing and how you use that. So we are able to clean this. As I mentioned, we would like to also get into extracting the data, the important data, into reports. So there is not you can then clean the task and not losing all the data that are included there. So the short answer is there is cleanup mechanism on the Foreman task side to help with that. So the question is, how do we handle long-running requests? I'm not sure if this is a question for the requests that run against the SSH, or these are the requests from the Foreman to the Foreman proxy. Anyway, in both cases, the request should be really fast. There is nothing that should block the request other than loading the data from that base. So once the command gets from the Foreman to the Foreman proxy, we hand it over to the Dimeflow executor that handles all the things asynchronously and just provides the task ID back. The same goes when getting the results from the about the task from the Foreman. For the real-time updates, we again just load the data from the Dimeflow database, and at the end, when the task finishes, we have this callback action that sends the data back to the Foreman. So also on the Foreman side, it means we just hand over the data from the web server to the Foreman or Dimeflow executor. So this is handled asynchronously as well. So we try to minimize the long running requests if we are talking about the communication between Foreman and the Foreman proxy. For the communication between the Foreman proxy and the host, so the SSH calls, we don't wait for any output on every host. We basically ask in some periodic interval if there are any updates on this particular connection, and if so, we send it back to the Dimeflow action. This is probably for the next another deep dive with even lower level focus, but the short answer should be there should not be long-running requests. Another question, when we say asynchronously, does it mean that TCP SSH connection is not kept, or is kept but not blocking any thread on the proxy? Yeah, we keep it, but not blocking the thread. So we basically, you can think about it as iterating over all the opened connections and asking if there are any updates. And this happens on periodic interval rather than waiting and blocking on every session for the updates to be there. And there is one comment, we need to adjust the limits conf so that proxy can create many sessions. Yeah, we will probably hit this as testing and running this on bigger infrastructures. So yeah, there are probably more things that we can tune to get the best results. So these were the questions about the general architecture. I would now like to talk a bit about the authentication and how this thing works. So in the manual, there is description how we can enroll the hosts in there. So right now we don't do any SSH keys management in the Foreman server itself. The Foreman proxy is configured to use some keys to connect to the host, and what the host needs to do is getting this public key into their authorized keys. So either you use tools such as SSH copy ID with this public key. We also publish this public key in the Dimeflow on the smart proxy. So this is the public key that I used for this demo. This is how basically one configures the keys. Another part of the authentication is verifying that the host that we reached to is the host that we want to address. And there is on the backend side on the Smart Proxy Remote Execution SSH plugin, there is preparation to get the public key of the host as the argument. So basically, here we would get the public key of the host that we want to reach to, and we would refuse the connection if there was another public key of the host. On the Foreman server side, this is not implemented yet, but the plan is to load this either from facts or from parameters on the host. Ideally, some combination of those, so you can use it both if you have Puppet involved or not. And yeah, so this is the other part. So authentication of the proxy against SSH is done using the private key that for now is, we assume, just one. We did so basically to not increase the complexity at the beginning and wait for the feedback from the users. So we're not saying we don't want to implement something more complicated or more complex, but powerful. But we need first some feedback from the users. What would be the best way? So I guess that should answer the question. And a related question also is auto-importing the SSH keys from the post-provisioning of the host. We more assume that we could get the SSH keys from the Puppet, if we're talking about the SSH keys of the host, and yeah, importing the keys into the host might be done in several ways. So the question is what way to choose to automate the process of enrolling the host. We could either use the provisioning scripts or maybe Puppet modules, another question mark, or something else. So we don't have the definite answer yet. So another question, what happens when triggering rerun for a host that still have not finished their first call? We don't block this for now, so you can execute as many commands as you want on a given host. If you run a package install twice and you get logs from the YAM, so YAM refuses to execute the second call, you just get the task as failed. And a question, some actions might be expensive on how many hosts might run. So basically, if I understand you correctly, the question is about denial of service if you run YAM update on thousands of hosts. We have designed for this and plan to tackle this later. So we'll talk about that briefly in the future plans. But yeah, we definitely want to handle this thing, and we will probably do so by involving splay times and basically controlling how many tasks get executed at a given moment, probably from the Foreman server side. So another question, we are running out of time a bit, but I would like to get your attention on another thing that we would like to get feedback on, or just that this thing is there, and it's an advanced topic in our manual on the Foreman org about.
Sorry, font size, please.
Yeah, thanks. So right now we do some assumptions about choosing what smart proxy to use when executing the command. So if you remember this script, the invocation gets on the Foreman server side, and then we need to select which proxy to send the command to. And this is basically what these paragraphs are talking about. So right now there is no explicit connection between the host and the smart proxy to be used for the SSH or for the remote execution. So what we do right now is iterating over the smart proxies that are assigned to a host in some other roles, and if the smart proxy has the SSH feature in there, we'll use it for the SSH execution. We are aware of the fact that it's not applicable for all cases, but it was the simplest way how to use the data that are already in there. And because another thing that we would like to tackle, or this question mark, is ability to spread the SSH calls across multiple proxies, so it's kind of load balancing. Another question that we haven't talked about is multi-provider setup. So we don't limit ourselves to SSH only. So there are then questions if there was mCollective or Ansible or Salt or whatever in there, and the host supports both of them, or one host wants to use mCollective, another host wants to use SSH. or the admin wants them to use that, how to determine these cases. So this is something that we have planned to improve, so we can also expect some discussion upstream for this setup. So right now we just choose whatever proxy is available for the host. So we respect the connection from the host to some proxies. Plus, there is the setting recommended mainly for testing, when you can say use the first smart proxy with the given provider. So this is quite useful for proof of concept setups that I just registered a couple of hosts, and I don't want to worry about assigning the host to the proxies because I have just one proxy for the SSH. So this can be used as fallback if you don't want to spend too much time setting up and just see the remote execution in action. So that's probably all I had for the second part, which is the talking about more about implementation details. And the third part, we are out of time already, so just briefly, if you are interested of what's going to be next, I would like to redirect you to our project pages, where in the roadmap you can see that we are already in iteration 2 that should end sometimes in the middle of the September, and there's also already a couple of tasks that we would like to address there. So you can see that we want also we would like to tackle the running the task in the future and handling the reoccurrence, so repeating the task every night or every week or whatever you need. Another things that to tackle is ability for the other plugins or the core to reuse the features that we provide from their side. So if you have Puppet run in the Foreman core, there should be a way how to map this functionality to the templates that are available in the remote execution. The same goes to the catalog and the content actions such as package install or errata install and things like that. Also there is the design page for this feature. Another thing is showing the tasks or the command outputs as they go. So if you run yum install, you should see the progress right away. So that's another thing that you can look forward to. And yeah, a couple of the things already are in pull request state or even merged. So this is what we have planned for this iteration, and in the issues we track more things that we would like to handle. We wanted also to talk about the UI and the wireframes. Unfortunately, we don't have time for doing so right now, but you can look up on the Foreman dev the wireframes that we go by. So we haven't implemented all the things that are in the wireframes, but we take it as inspiration and some things that we'll implement later. So I don't see much more questions there. If so, we will try to answer them online on RSC or in the Foreman dev. So we will send the recording of this deep dive to the Foreman dev, also with the important links and other useful information. So thanks all for your presence, and see you later.
Thanks. Bye.
Bye.